Hello, my name is Krista Larson and I'm a developer on the glideinWMS project, a Glidden-based workload management system that works on top of Condor. We provide a simple way to access and reuse grid resources while shielding a user from the details of the grid. In our system, we have two services that can request Glidden resources. Here I will show you how to provision Glidens for a Pegasus workflow using our Corral Frontend. For our example, the workflow is generated by Pegasus. The input is an abstract description of the workflow, catalogs that describe the files, and the site information for where the jobs will run using Glidens. Pegasus will map the workflow to the resource and then generate the DAG and submit files. Because of the grouping Pegasus does, there will not be a huge number of jobs, but the workflow fans out quickly, then down to a single job, which is the background model, and then fans out again. The example workflow is using NASA IPAC Montage to combine many images into a single image, for example using those taken by the NASA space telescopes. The workflow takes in the inputs for a specified area and does the following: reprojects the images, checks how they overlap, runs a background model to match up the images, applies background diffs, and then tiles the images together. In our example, the area is for a 4 degrees by 4 degrees tile with an input of 787 images. The output will be one seamless image. We have already set up all the software and data as well as Condor resources needed for submitting jobs. We also have the Condor resources for matching the Glidens in our local pool to the jobs from the workflow. To use Corral, you will need a long-running grid proxy that will stay valid for the length of the workflow. To begin, we create a config XML file that contains the information needed to get Glidens from a site. Here you will see that we specify the Condor collector for the Glidens to report to, the owner of the jobs, the site name from the Pegasus site catalog, the resource type, the factory service we will be using, the entry name in the factory, which is the site we will be getting Glidens from, security and authentication information, including DNs, so we can communicate with the factory in the local pool, and finally, the number and rates of Glidens we will need for this workflow. Before we begin, I want to point out that at any time you can type Corral help for a list of available commands. Now we will begin the example. First, we create the provisioner and give it the config file. We can now see the provisioner we have created at any time by using the Corral command list provisioners. You can also remove them, but we won't do that here. See the Corral help for more details. Next, we'll start the workflow. You will see some output that describes the details about your submission. This includes the Condor files and the base directory, which will be created by the submit process. It also lists commands for how to monitor the workflow and how to remove it if you need to. The submission process can take up to several minutes to start, but we've condensed it here. This output is also saved in the work directory for this workflow in a file called pegasus-plan.out. Now that we have started the workflow, you will want to monitor the jobs. You can check the status by using Pegasus queue, which is just a wrapper for Condor queue. This shows what jobs are in the queue and their status, such as idle or running. We can also check registered resources with Condor status-any. At this point, Corral is watching your job queue, and if the demand exceeds available resources, new Glidens will be provisioned. Here you can see the Glidens have started and reported to your local Condor collector. And since there were jobs that were running, the negotiator has matched Glidens to jobs. We can also view a graph of the provisioning in real time. As the workflow fans out with lots of jobs, you can see how more Glidens are requested. Once the Glidens connect to the local pool, the jobs are matched and start running. As time goes on, no new Glidens are requested because the Glidens are reused for other jobs waiting in the queue. When the workflow has completed or has failed, cd into the directory of the config file and run Pegasus Analyzer-Q. Here it says all jobs were successful. Now we can see the outputs by cding into the outputs directory and listing the files there. Here is the output image from the workflow. Note that this is just one wavelength, so that is why the picture is in grayscale. So for our example, all we had to do was submit our workflow and the glideinWMS system provisioned the resources that we needed. Our local counter pool grew or shrank depending on the jobs in the queue. The glidins also allowed us to reuse resources so we don't have to provision new glidins for every job. Hopefully we have demonstrated how glidins and glideinWMS can provide a simple way to access grid resources. Thank you.